Hello, um, warm greetings from me. Hope everybody is staying safe and healthy. So, we will continue the video number 2. So, last class we have discussed about the basic concepts which is related to one-dimensional problems. I have touched upon some basics which is required on the problems point of view. From this class onwards we will start a basic problem, and on the coming videos we will go for some complex problems. So before getting into the problem, so I would like to touch upon the few basic formulas which we would have already derived for one-dimensional bar element. So this is your general finite element equation which we already discussed in our previous video, which is F equal to K into U, where F is your force matrix and K is your stiffness matrix and U is your displacement matrix. So as far as your second unit is considered, for the first of most of the problem, your unknown matrix will be of displacement. We will be given a set of conditions. You would be given a problem with with different boundary conditions with related to be the physical structure and the loading conditions, and we will be calculating this unknown displacement at any specific point. So this is the form K matrix, and this is the stiffness matrix formula for one-dimensional bar element AE by L 1 minus 1 minus 1 1. This is the stiffness matrix formula for a two-noded bar element, and this is your force matrix and displacement matrix, and these both your force matrix will be the unknown matrix which we will be calculating at the end of the problem, and force matrix will be assigned based upon the boundary conditions which is given in the problem. So this is what this this is what we applied in the above. So we have applied F here, so you get F. We applied K here, stiffness matrix, and we apply U here. So this is your finalized formula. This is the finite element equation for a two-noded bar element. So we might have a different number of element. As we discussed in our previous problem, we will divide a simple problem into a finite number of elements. So that is how. So now we will see our first problem. So before getting into the problem, I would like to stress upon a point. So as for your first one-dimensional bar element problems are considered, you will be given a problem with a set of a physical structure and a boundary condition. So how you divide your full element into a number of small elements, that depends upon few conditions. You can either go for a simple minimum you need to have two elements, without having with less than two elements. So as the number of elements increases, your solution, the approximity of your solution increases. That is how the FEO works. So the number of elements depends upon you. So what are the next condition? So we will go for, as for your solving a problem in a paper is considered, we will go for a minimum number of elements which will give us a solution, approximate solution. But still we have some other condition which has to be considered before dividing an element. So the two main thing, there are few other conditions which we already discussed in our previous video and classes, but the two main thing which is considered as for the coming problems is the first one: whenever there is a change in area, whenever there is a change in cross section, definitely you have to specify and note that, hence you will get a different element. So whenever there is a change in loading condition, whenever there is a load on in between the structure of the end of the structure, wherever it is in that specific point where the load acts, you are supposed to provide a node, so that you should have a division. So please stress, I stress upon this point again. Please remember, this is very much important. As for the problem is considered, minimum you should have two elements, and also whenever there is a change in the cross section, you have to specify an element. Whenever there is an load applied, you have to specify an element there. So this just have in mind, and this condition, with this very much required for solving the coming problems. Now we'll go for the first problem. A steel bar of length 800 element is subjected to an axial load of 3 kilonewton. Find the elongation of the bar neglecting the self weight. So this is the simplest problem which you can export from one dimensional bar element. So in this, so they have provided the Young's modulus, which is 2 into 10 power 5 Newton per mm square, and area, cross sectional area as 300 mm square. So this is your given figure. So it is a cantilever bar which an given load at the end of the element, end of the bar, at 3 kilonewton. That is an axial load. So you already know what is a bar is. So bar is an element which resists only an axial load. So this is your axis. So this element obviously is an resisting an axial load. So hence it is a bar. So hope you are clear with the questionnaires. So you have a bar whose length is 800 mm, and so how many elements will go with? You go with. It depends upon individual. So as for this problem is considered, you can see here they have gone with 2. Minimum number, minimum you should have 2, because here you can see you have a same cross section throughout this length of the bar, so you no need to specify any additional element, and you have only one load at the end of the bar. So hence either you can divide it into half. I am dividing this into an half. That is what you can see here. I have divided this whole element into 2 elements. This is element number 1, this is element number 2. So length of each element is 400 mm. So this is node 1, node 2, node 3. So length of the element is 800. Young's modulus they have given, area, cross section area they have given, force it is 3 kilonewton. I have converted into Newton. So before starting into any problem, you should remember, as for your FEA is considered, before starting your problem you have to do all the unit conversion. It has to be in a specific, either if it is Newton, it's a Newton. If it's a meter, you cannot have Young's modulus in Newton per mm square, and you cannot have your area into a meter square. That will give even wrong result. Already FEA is an approximate result, even if approximate solution. If you do some silly mistakes, then it is no meaning of using an finite element analysis in your problem. So before starting the problem, make sure that all the given units are in same SI unit. Now, so as you know the FEA procedure, your first step is discretization. That is, you have to divide your whole element into finite number of elements. So here I have divided the element into 2 elements. So 400, 400, 1, 2, 3, 3 nodes. So you have 3 nodes. You have 1, 2, 3 nodes, and you have 2 elements. So as you know, last class, as we discussed in our previous video, so your final stiffness matrix will be a 3 cross 3. How it is 3 cross 3? It's very simple. You have 1, 2, 3 nodes. If you have 3 nodes in your problem, then you will have a 3 cross 3. So now, as we see in our previous slide, this is the finite element equation. This is the finite element equation for one dimensional bar element. Now you have to apply this equation to your node 1. You have to apply the same equation for your node 2, and then you have to assemble both. That is your FEA procedure. So for this node 1, your force will be F1. At node 2, your force will be F2. At node 3, your force will be F3. Similarly, at node 1, your displacement will be U1. At node 2, your displacement will be U2. At node 3, your displacement will be U3. So here they have asked to find out the elongation of the bar. Elongation of the bar is nothing but how much this bar elongates at this point due to this 3 kilonewton node, which is nothing but the displacement. If you calculate displacement at this point, then you will able to calculate the elongation of the bar because of this load 2. So now we will apply the FEA procedure. You already know the FEA procedure. Now we will apply the FEA procedure. So for element 1, I have applied the FEA procedure. So it will be A1, E1, L1. This is your matrix, K matrix U1, U2, F1, F2. So as for this problem is considered, this A cross sectional area, so if you cut here wherever it is, your cross section will be same 300 mm square. So this A is constant, and also Young's modulus, so it has a same material, so you have a same Young's modulus throughout this material, so it is also constant. What is L? L also constant, because you have divided into and 2 equal halves, so therefore your length will be equal. So you will get 300 into 2 into 10 power 5 Young's modulus 400 U1. If you simplify this, you will get as 150 into 10 power 3. So this is your finite element equation for your element 1. Similarly, for you will go for this is regarding your assembling. I will tell you next step how to assemble this. So you go for an element 2. I am applying the same finite element equation for the element 2. You have A2 E L2, but whereas A1 and A2 are equal, because your cross section of the bar is same throughout your element. So this obviously will be again 300. Young's modulus, you have a same material, again it is 2 into 10 power 5. Your length is also, since we have divided into equal, it is 400. So this equation will be moreover same. But now we come for this U matrix. U matrix, this is your first element. In first element you have involved 2 nodes, node 1 and node 2, hence you will have U1, U2. And also you have involved with force matrix F1, F2, so hence you have F1, F2 for element 1. Similarly, when you come for the element 2, this is your element 2. In element 2, you have node 2 and 3. Therefore, your U matrix will be U2, U3. Similarly, force matrix will be F2, F3. Now you will go for an assembling. Now we have to assemble matrix equation 2 and equation 3. Therefore, you will get your final stiffness matrix, based on which we will able to calculate your displacement matrix. So all you will assemble. So for that you have to give the address for this matrix. In order to give address, you are supposed to take a pencil and write the addressing of this. So this is, for this it is element 1 and 2. So your address will be 11 A11 A12. So this is first row, second row, first column, second column. So you know the numbering. So now this is 11 12. Now this is second, first column, so 21. This is second row, second column, so A22. Then how about here? Here you have the element numbering, node numbering 2 and 3. So you have to start with 2. This is second row, third row, second column, third column. When you come here, you have node 1 and 2. So first row, second row, first column, second column. Whereas when you come for element 2, it is 2 and 3. So you start with row 2, row 3, column 2, column 3. So obviously you will get A22, A23, A32, A33. Very basics. We should not spend much time on this. Now we will see how to assemble 2 and 3 now. So you have to combine this 2 and 3. So this constant will be same. You can see will be same. Now you write the matrix. So obviously you know. So since we had three number of nodes, you know, obviously our final K matrix will be of 3 cross 3, 3 rows, 3 columns. You just write the numbering A11, A12, A13, A21, A22, A23, A31, A32, A33. Now you go to here. You take these. What are the respective values? You just take and put it here. So you have, see here, so the only thing which is common in both this matrix is A22. You have a A22 here, we have an A22 here. When you combine this, you have to sum it 1 plus 1. That's the only step here. 1. So finally, this is your final matrix. So obviously, when you combining both U matrix, you will have U1, U2, U3, F1, F2, F3. So this is your stiffness matrix. Sometimes in some problems they would have asked, if it's a simple problem. In some complex problems you will have 6 cross 6 matrix. In that cases, for example, if you divide the same problem into 5 different elements, then obviously you will have 6 nodes, right? So number of element plus 1 give you the number of nodes. So obviously if you divide the same problem into 5, then you will have an plus 1 equal to number of nodes 6, then you will have a 6 cross 6. That is how the problem goes. So in some problem they would have asked just to write down the stiffness matrix, so your problem will end here, but in this cases they have asked to find out the displacement matrix. Now you can see this. So this is a gradient matrix. So as we have seen in our previous video, we would have seen that it is a symmetric matrix above the diagonal. You just you see that diagonal, it will be symmetric. So minus 1 0 1 on the other side. This is just mirror image. If you take 1 2 1, if you put a cross here, you keep a mirror. If you keep a mirror here, the image, this side image, that will be just an opposite, minus 1 0 minus 1 minus 1 0 white 1. And also if you sum it, if you sum any row and column, it will be 0. After completing the matrix, K matrix, you can check whether the arrived K stiffness matrix K is correct or wrong. How you will do it? I will do it. Just add any row or column. Just if you add first row, what happens? 1 minus 1 0, it is 0. If you add first column 1 minus 1 0, again it is 0. If you add second row minus 1 2 1, again 0. So that is how. So now this is the correct problem. Now we will go for the boundary. And this is the first step also. We have applied the discretization. Now we have applied finite element equation for element 1, finite element equation for element 2. Now you combined and assembled, and we have got the final finite element equation. Now your next step, which you have to remember as per our FEA procedure, is you have to apply the boundary condition. What is the boundary condition here? Very simple. The boundary condition will be depending upon your physical structure and loading. Okay. So at the end result of boundary condition will be just the value, finding out the value of u and f, right? So in this problem, you are supposed to calculate the u. Depending upon the boundary condition, certain f formulas will be known from the problem, and certain will be unknown. That unknown you have to calculate. So at the end result of your boundary condition will be the values of either value of u, or either the u and f will be unknown. So now you go here, you go to the problem here. So what is the boundary condition here? So in this you can see here it is in cantilever. So this here it is arrested. This side, one end of your cantilever bar is arrested. So node 1, there will not be any displacement. If you pull it after node 1, these places you have a gradual elongation, but at this point there will not be any displacement because that point is completely arrested. So your first thing is u1 is 0, whereas u2 and u3 is unknown, that you have to calculate, right? You don't know how much it is, but u1 is 0. That is the first boundary condition. You can see u1 is 0. Similarly, in this part you can see only one force which is acting at the node 3. So in node 1 f1 it is 0, there is no load acting as per this drawing. Node 2 again it is 0, so f2 is 0. At node 3 alone, again and another force acts, 3 into 10 power 3 Newton, so 3 kilonewton. So that will be your value of f3. So that is what we are. So you apply now. u1 is 0, f1 f2 is 0, obviously, since no. So self weight will come to the next problem. We will see how, if self weight, the density, if you have to solve the same problem considering the self weight of that bar, that we will see in the coming problem. As of now it's neglected, just neglect it in this problem. So u2 u3, how will you do it? So you have 0, this is 0 as per your matrix conditions. You can neglect first row and first column, you neglect first row and first column, you will have this. So if the multiplying matrix first value is 0, as per your matrix condition, matrix solving shortcut, what is first row and first column is 0. If either, for example, if u1 is unknown, u2 is 0, u3 is again unknown, then if u2 is 0, what you do? You can neglect row 2, column 2. So these 4 values you will get. But as for this boundary condition is considered, u1 is 0, so I am neglecting row 1 and column 1, and I have given here. Now this, you expand this. Now you know how to expand this. Now expand this into equation. Now you have applied the boundary condition. Okay, hope you are understanding what is boundary condition is. So boundary condition is just refer to the problem, just find out what is the u and f value, and also check whether a density is given in the problem or not. If density is given, then we have to include a formula that we will explain in the next problem. So your density is not given, so sulfate is neglected. So now you expand these two. That's simple. That will be end of the problem. This is the last slide of this problem. If you expand this, just take this row 1, multiply with this column, you will get one equation. Second row, again multiply, you will get another equation. So you have two equations, two unknown. Very simple. You can calculate using your calculator. Hope you know how to do that using your calculator. Just a minute work, or else you can, as usual, you can sum it up. If you sum these two equations, this u3 will be neglected, so this will be 150 u2 equal to 3 into 10 power 3. So from that you can calculate u2. Again, after calculating u2, substitute here in any one of the equation, calculate u3. That is the end of your problem. So the result what is asked in your problem is elongation of the bar. Where it elongates, so u1 it is 0, there will not be any elongation. At the point u2, there is an elongation of 0.2 mm. This unit that depends upon, so you can see in this thing there will not be any unit. So in the given problem, there you have to fix your unit. If you are fixed with meter, then your end result will be on meter. If you fix on mm or centimeter, that will be your end, this one. So now your end result will be u1, u2, u3. Elongation at point 1 is 0 because the node 1 is completely fixed. u2 is 0.02 mm, u3 is 0.04. This is the simplest problem which you have to understand. Once you are done and clear with this concept, in the next problem we will solve and complex problem. In the coming videos we'll solve complex problem. That's it for the day, guys, and thanks for watching. If you have any comments for suggestion, please post in the comment section so that I can improve in my coming videos. I know this is a very basic problem, but still you have to understand the basics, then you can only go for a complex concept. So in coming videos we will go for an complex problems, and they will solve many university problems. Thank you, guys. Have a nice day. Stay safe and stay healthy.